Student, we discussed in the previous session classification of colloids on the basis of interaction between the particles and also classification of colloids on the basis of nature of particles present in the colloid. Now let us see properties of colloids. Colloids exhibit important properties. And this session, in this academic year, 2 colloidal properties are included in the syllabus. So, today's topic is properties of colloidal solutions. Properties of colloidal solutions. And we have 2 properties. One property is electrophoresis, and the other property of colloidal solution is Brownian movement. Now let us see about these properties. First one is electrophoresis. What is meant by electrophoresis? Phoresis refers to movement. Electro refers to charge. So electrophoresis means movement of charge towards a particular electrode. This is the meaning of the term electrophoresis. So under properties of colloids, we have number 1, electrophoresis. Once again children, electro refers to charge, phoresis refers to movement. Means in a colloidal solution we can separate the particles with a particular charge. Right? How is it separated? Let us see. In this we have U-shaped tube, right? And in this U-shaped tube we have 2 electrodes made up of platinum. This is one electrode. This is in the other limb. We have a different electrode, right? And we have taken in this colloidal salt, in this U-shaped tube. Okay, and this electrode is connected to, these 2 electrodes are connected to a battery of suitable voltage. Imagine this electrode is connected to a particular electrode which has positive charge. Particular terminal of the battery, this electrode is connected, and that terminal has positive charge. Therefore, this platinum electrode will have positive charge. Right? Positively charged electrode is called anode. So this has positive charge. And this electrode is connected to negative terminal of the battery. So this electrode will have negative charge. So it is called cathode. So here cathode has negative charge. Remember, cation will have positive charge always. Cathode, negative charge. Anion always possesses negative charge. Anode, positive charge. Now in this, imagine we have taken, in this U-shaped tube we have taken, right, colloidal solution. And imagine the particles specifically which have positive charge in the colloidal solution. This is one particle which has positive charge. Right? This will move in this direction. Positively charged particle will be moving in this direction towards cathode, since cathode has negative charge, right? So after a particular time, those particles can be seen around this electrode, because this electrode has negative charge. So all positively charged particles will be moving towards cathode, right? So dispersion medium is this. So moment will be like this. In this way you can show. Otherwise, you can show movement of what you call negatively charged particles towards this positively charged platinum electron. In any way it can be shown. At least one sort of particles with a particular charge and its movement towards an electrode with opposite charge. We need to show. And this is dispersion medium. So here this figure represents electrophoresis, wherein the particles with a particular charge or the particles which are having particular or the specific charge will be connected towards oppositely charged electrode. So importance of this electrophoresis phenomenon is separation of particles in the form of aggregation or precipitate or in the form of coagulated material. So here we have one more concept, that is electroosmosis. We know osmosis means movement of solvent particles. Electroosmosis means movement of water molecules or solvent in presence of electric field. That is called electroosmosis. Okay, movement of solvent. It can be water, right? Movement of solvent, water, or it can be written in this way also, dispersion medium. In presence of electric field. Right? Is called electroosmosis. So here it can be solvent, water, right? Or in general we can write dispersion medium. So this dispersion medium can be solvent, any solvent, or it can be water. Fine. So that's about the one more concept which is associated with this. We'll move to the second property of colloids. Second property of colloids, let us see. It is Brownian moment. Brownian moment. What is meant by Brownian moment? Let us see. This phenomenon was observed first time by the botanist Robert Brown. That is why this phenomenon is known after his name as Brownian moment. Brownian moment means zigzag movement of particles is known as Brownian moment. Here particles always refers to that of dispersion medium or colloid, not the dispersion medium. And it can be like this. Zigzag movement can be shown in any way. It will not have particular direction. Right? So this is called zigzag movement, and this zigzag movement is because of the collisions between the particles, right? Or when particles undergo stirring, then also this Brownian moment is exhibited. So that's about Brownian moment exhibited by the particles of colloidal solution. So this was observed first time by the botanist Robert Brown. That is why this phenomenon is called after his name as Brownian moment. So electrophoresis, Brownian moment. These are the very important properties. Now we will move to one important concept, that is as per the latest syllabus of this session. So as per the latest syllabus of this session, the topics which are included this academic year, that only I am going to teach. So electrophoresis, Brownian moment over. Now the important one is coagulation. In the previous session I taught clotting, coagulation, precipitation and aggregation. All these four terms means same. So coagulation means aggregation of particles to form precipitate. Is called coagulation. How is this coagulation occurs, and what are the different factors which are going to make this coagulation to occur? Let us see. In the case of colloids, example leophobic colloid, if we add electrolyte, then all the particles of that dispersal medium, particularly in that colloid, will come close to each other to form aggregation, right? So by the addition of electrolyte, this coagulation can be carried out. Next, by means of giving small amount of heat energy, coagulation can be carried out. By means of electrophoresis, coagulation can be carried out, right? So different techniques are there in order to make the coagulation to occur. Even by stirring also, by stirring process, coagulation can be made to occur. Now let us see the important factor that makes coagulation to occur fast. What is that factor? Let us see. The balancing of the ions, particularly positively charged ions or negatively charged ions. If balancing of a particular ion, example, look at this, aluminium has +3 oxidation number, valence 3. Next, barium +2, sodium +1. Now, if coagulation is taken into account, the ion which has highest oxidation number or balancing will rise the coagulation power, right? In the case of cations which are there, if anions are there, same thing is applicable, like PO4, this has -3 charge. SO4 has -2 charge. Cl has -1 charge. Now one which has highest oxidation number or valency will be accountable for the coagulation to occur to the maximum extent. Right? And this is nothing but Hardy-Scully rule. Hardy-Scully rule. So Hardy-Scully rule states that particles whose valencies are very high will be accountable for the coagulation to take place fast. So the colloid which has this ion Al+3 and also Bl+2, separate two colloids are there, and if we add the electrolyte whose valency is more, that will bring about this coagulation fast. That is the meaning, right? That's about coagulation phenomenon and the factors that can bring about the coagulation, and then the Hardy-Scully rule. Once again, coagulation refers to aggregation of the particles. Aggregation of particles is possible between oppositely charged particles. They can come, attract each other and result precipitate. Or the particles lying in the dispersed phase can be made to settle down in the form of heat or aggregate with the help of heat energy, and even by adding small amount of electrolyte, and even by electrophoresis phenomenon. See, in electrophoresis what is happening? Particles of particular charge are shifted towards one electrode, thereby form aggregate there. And even by stirring process also coagulation can be brought about. Next, coagulation power can be increased if the valency of the ion or oxidation number of the ion is very high. If you take cations, for instance, out of these, aluminum has highest oxidation number, right? Or its valency is very high when compared to the other ions. Therefore, coagulation can be brought about with that particle whose valency is very high, right? Those particles may be possessing negative charge or positive charge, and this is nothing but Hardy-Scully rule.